Hello everyone. Welcome to the video lecture series on Z transforms. I am Professor Mayur Gohil. In this video lecture, I shall be dealing with one very important property of Z transform, which is multiplication by n. Now, this property has certain important understanding regarding operator. So let us see the property first and then we see the details. So the statement says here that if there is a Z transform of a sequence Fn whose answer is f of z, okay, then Z transform of n to the power r times f of n is equals to minus of 1 to the power r z d by dz whole to the power r f of z. Now, on the first layer of understanding, it is very difficult to understand what does it try to tell us. So let us try to understand what is the whole meaning of this statement. Now, in this statement, or most of the questions related to transforms, Laplace, Fourier, etc., everywhere you have if then kind of statement is there. So what is the thing here? Then you have this Z transform of the sequence f of n denoted by capital F of z. This statement is the base statement, okay, in which there is an input. This is the input, okay, this is the input, and this one is the output. Now, what is the thing the statement trying to tell you? That the statement says that if there is a change in the input, the change in the input over here is n raised to r f of n. This n raised to r component is multiplied to the sequence. Then what is the change in the output of the sequence? So the change here is minus 1 to the power r z d by dz whole raised to r f of z. This is the change that you observe. So while solving the questions of transforms, it is extremely important that you work upon LHS as well as RHS. So you have to check each time what is the LHS. Accordingly, you have to act upon the RHS. And you must have the base statement, that is the foundation of your next step. So this is multiplication by n. We will see this property in detail because here this is the place where the operator has come into the picture. So I'll just show you what is the operator. This is the operator. This portion that you see is the operator, okay. I'll just write here operator. Now this operator has a different way of understanding. We will see how to solve questions with its help. So now suppose that we are given a sequence f of n is 1. We now know that the Z transform of 1 is z over z minus 1, and we already know that the condition over here is 1 is less than mod z. That is okay. We don't have to bother about the condition right now. Now we want to find the following expressions, that is Z transform of n and Z transform of n square. How do we start about it? So consider Z transform of n. This n can be seen as n into 1, okay. Now you observe that this is basically the format of our property of multiplication by n. So we can see that this is almost same, right? Instead of n to the power r, we have n to the power 1. So here n to the power 1 is there. So I use that property That property says minus of 1 to the power 1. Instead of r, now I have 1 in the power, and z dz, and this f of z. What is f of z? F of z is the z transform of the fn. So z transform of fn is z transform of 1. Okay, that is what we have to write here. Now this operator that you see is actually operated upon the z transform of 1. Okay, and then z transform of 1 is z over z minus 1. Now we do the derivative. So while doing the derivative, we need to remember the formula u by v derivative. When you have to do, the formula is v square v into u dash u minus u into v dash. Okay, so this is the formula for u by v derivative. So using that formula, we will get our answer as z transform of n is equal to z over z minus 1 the whole square. So using the formula of multiplication by n, or the property, we get here z transform of n is z over z minus 1 the whole square. Now we remember this as a formula because this will be used later again. Now we find z transform of n square. So let us see how. Z transform of n square, when we want to do, we can write this n square as n into n. Now we can observe here that our this n is the portion in which the formula n to the power r is going to be applied, and this one will behave like the function f of n. So we know over here the z transform of f of n. So f of n, we are now treating f of n as n. So z transform of f of n, meaning z transform of n, that is known to us, which is z over z minus 1 the whole square. So I am now in a position to apply the multiplication property. So it will now become minus of 1 to the power 1 z d by dz operated over z transform of n. So this operator is now operating over z transform of n. So z transform of n is z over z minus 1 the whole square. I now take the derivative. While taking the derivative, I get this expansion. We again use the same u by v formula. So I'll just write here u by v derivative formula. So it is going to be v into u dash minus u into v dash, the entire thing divided by v square. Okay, so we do that and we do the simplifications, and we get our answer as z transform of n square is z into 1 plus z over z minus 1 the whole cube. Or further, if you want to simplify this and write, you can write this as z square plus z divided by z minus 1 the whole cube. Please remember these two formulas all throughout because we would need them at later stage when we do inverse z transform. Okay, so these are very important formulas that we will need. Now let me give you some advanced formulas. Here z transform of n cube is given by this z cube plus 4z square plus z upon z minus 1 whole raised to 4. Also z transform of n raised to 4 is given in this way: z raised to 4 plus 11z cube plus 11z square plus z over z minus 1 whole raised to 5. I would request you to learn these formula, that because they are going to be very important when we go for something called as inverse Z transform. So I would request you to learn them so that it will help you to gain the much more detail while solving for inverse Z transform. I would like here to tell you how to find the Z transform of n cube and Z transform of n raised to 4 as well as Z transform of n square. There is an alternate method. So let me show you that alternate method. So see, the method that we used for finding Z transform of n square, when it was there, we used here n into n, right? This was the method. Now instead of doing this, we also can write this here as Z transform of n square is same as Z transform of n square multiplied by 1. This is also possible. Now when we do this way, what do we get here is minus of 1 to the power 2 times z d by dz the whole square operated over Z transform of 1. Now when we do this way, minus of 1 square becomes 1, and here what we are left is Z d by dz square operating over Z transform of 1 is Z over Z minus 1. Now comes the most important part of understanding what is this operator trying to tell us. How can we work upon this operator? This is what was the main part that I would like to tell you over here. This operator has its own understanding and its style to solve. There are ways to solve when operator comes into the picture. Either you solve the entire operator or you take it part by part. Now let me show you how to work upon it. So we consider this operator first. You can work this way. I am going to do the little bit advanced way to show you the technique of understanding the operator. You can opt this way also, d by dz, z d by dz, because it is the square that will operate over z minus 1, and then you actually do this method. So z d by dz, okay, operate this now is operating, this derivative is z over z minus 1. Take the derivative and get it done. So let me just show you that calculation here. So when you do that calculation, you will get z d by dz the operator as it is, and this answer will give you minus of z over z minus 1 the whole square. You take the derivative and do the multiplication, you will get that. Now this one is going to be minus of z d by dz operating over z minus 1. At the denominator there is a square. So again when you operate this whole thing, you will get your answer to be minus of z times minus of z plus 1 divided by z minus 1 the whole cube, and this on simplification you will get here z square plus z over z minus 1 the whole cube. This is what you would get. This is when you solve operator by operator. Okay, so this portion over here I would like to tell you that at this step there are two ways here. So this method when you did was this whole thing that you have done, this is called operator by operator. Operator by operator when you do operator by operator. So like I have first operated this on this term, then I got it the answer, then I take this operator, the second operator getting operated upon the answer, and I get the final answer. So this is operator by operator. Now let me show you one more way when you can solve the operator and get the whole thing done. So now this is what method I'm showing you is solving the operator. So what we do here, I'll write the whole step again. Z transform of n square is nothing but, we have already said it is z d by dz the whole square operating over z minus 1. Now we see this operator first. So this operator is basically telling me to do z d by dz, z d by dz, okay, and z over z minus 1. We don't touch this portion at all. For some time we won't touch, but now here we see this part. This means z d by dz operates over z d by dz. Okay, so over here what is applied is UV rule. The product rule will be applied. UV. So UV derivative when you do it is UV dash plus VU dash. That is the rule that has to be applied, right? So now when I do this, I have Z outside and I do that UV rule derivative. So I have Z double derivative d by dz plus, now we have this v outside and u derivative, so derivative of z is 1, so it is going to be d by dz. Okay, so what over here we got is z square, right? Z square d square over dz plus z d by dz operating over z over z minus 1. Now when I do this, I get z square d square by dz square. Okay, this is square over here. So then this is z over z minus 1 plus z d by dz operating over z minus 1. This answer when we simplify, 2z square divided by z minus 1 the whole cube plus, now this z d by dz, z over z minus 1 is nothing but minus of z over z minus 1 the whole square. Okay, and when you simplify this, you do land up on the same answer as before. You will get here your answer as z square plus z over z minus 1 the whole cube. So this is what is very important when you solve by operator. Now see why I showed you these methods, because as one thing is that we need to give flexibility to our understanding how to solve. Now operator by operator is a very basic way. When you solve the operator entirely, that is also one advanced way, but you should be very careful while solving for the operator. Now let me show you how to handle for z in cube, because this is the place where large number of people would fumble or go wrong. Let me show you how to handle z transform of n cube so we can do it easily. Now z transform of n cube can be seen as z transform of n cube multiplied by 1, and this by the property of multiplication is minus of 1 to the power 3 z d by dz whole cube operating over z transform of 1. Now we have minus of 1 z d by dz the whole cube operating over z over z minus 1. Now comes the difficulty, how to handle the z d by dz the whole cube. So we now see here, so we put one star over here and then we come back to this step. So consider z d by dz whole cube. This is nothing but z d by dz operating over z d by dz whole square. Now we have just found the value for this operator. The value for this operator is z square here. This is the operator value that we have found, right? This is the value for the operator z square d square over dz square plus z dz. So we now write here that z d by dz, okay, and this will be z square d square over dz square plus z d by dz. Let's operate them. Now when we are operating, we have to be very careful. Z d by dz is going to operate over z square d square dz square, and this one z d by dz will operate over z d by dz, right? Now this is essentially the operator which we have said as square. So what we have here is z d by dz operating over z d square by dz square, and for this answer over here we will again have here z square d square by dz square plus z d by dz, okay. And now we simplify the operator a bit. So we have z, here it will be z square d cube by dz cube, okay, z square and u v dash, okay, that is what is meant, and plus you have now 2z over d square by dz square. This is the derivative that you will have. So you multiply that, and here it is z square d square by dz square plus z d by dz, and this will be z cube d cube by dz cube plus 2z square d square by dz square plus z square d square over dz square plus z d by dz. This is the way operator works. So z cube d cube by dz cube plus 3z square d square by dz square plus z d by dz. We have got the value for the operator. This is the value for the operator z d by dz the whole cube. Now we substitute, so we put this in, put in star, we get therefore z to the power z transform of n cube, we get z transform of n cube is equal to minus of 1. Now we have the entire operator there, right? Z cube d cube by dz cube plus 3z square double derivative over here plus z d by dz. This whole thing gets operated on z over z minus 1. Now we need the answer. So minus 1 outside, z cube operate z cube times the operator operating on z over z minus 1 plus 3z square, the operator d square by dz square operating over z minus 1 plus z d by dz operating over z minus 1. Okay, this whole thing is under a bracket. So minus 1 outside, and then we have, we now go for calculating the each of the derivative. So derivative over here is z cube multiplied by minus of 6 over z minus 1 whole raised to 4. This is the derivative that you will get. You can calculate this by yourself. Okay, and then the next derivative that you do for double derivative of this is going to be 2 over z minus 1 the whole cube, and then this will be z times the single derivative. When you do, you will have minus of 1 over z minus 1 the whole square. Okay, so on simplification of this, we will get z cube plus 4z square plus z divided by z minus 1 whole raised to 4. This is what we must get. So I hope you have followed this example. And similarly, you can find the value for the n raised to 4. Okay, this is how the whole thing is done. I have given you the answer in the previous slide here. So that is the n raised to 4. I hope you can remember this. It is not extremely essential, but you will need it when you would do the inverse Z transform. So if you know, it would be handy, otherwise you have to work out the whole long way. So but I hope you can remember till n cube. That is very, very important. Okay, I hope you followed the procedure of solving operator by operator, solving the operator and getting the answer. So I have shown you both the methods here, that how to solve for the operator. So this is essentially what I have shown you, solving of operator. Okay, so this is where the operator value you get, value or expression you can call, and then you get the answer. I hope you liked it. Please go through the entire procedure because this procedure is very important in advanced mathematics. You may need it in future classes and other concepts also. Please hit like button, share it with your friends, those who find it useful. Please subscribe to my channel. I shall soon see you with the further video lectures on the topic. Thank you.